Imagine in 2006, when I was a student, I was just finishing my diploma thesis, and at this day, my professor came up and he asked me to do a PhD in injection molding. I said, thank you very much. It's a big honor for me, but I think I have another vision. I think injection molding will not be the future for all the things we do. I want to work in rapid prototyping. That is what we call 3D printing today, back in the day. And he said, really? Why do you want to do this? I said, I think in 20 years we have many, many more things we can produce with additive manufacturing or 3D printing, rapid prototyping, whatever you want to call it. And he said to me, Dominik, if this is your vision and you're declining my offer, then you should really go to a doctor. So I didn't do this. I found another university. I did my PhD in additive manufacturing. And afterwards, or one of the last projects I had was together with BMW. And afterwards, I was asked to join the team in order to do scouting with the aim to bring additive manufacturing towards serious production. And that's exactly what I did. And it's a real great honor for me to present additive manufacturing, how we do it today on this stage, especially with one product I really love. It's Mini. And I want to start with a short mood video about the product.
No hunters, no gatherers. We're all artists. Homo sapiens were the first avant-gardists. And these are no writings or sketches or tags. They're the marks we leave when we choose our tracks. The world is a picture without color and frame. Turn your thoughts into paint and sign with your name. Every you of you is a unique composition. You're no series production. You're a special edition.
And that was exactly the starting point. We were searching for the killer applications we might have in a playground like the BMW Group. And personalization was the first one that came up. So the question we asked ourselves was, what if we could use additive manufacturing in order to create our own special editions? Why Mini? Well, customization is part of the brand DNA we have at Mini. And the good thing is, compared to the other products, Mini is not normal. So sometimes we go beyond the standards we have and do a little bit more strange things on Mini. And since January, we have 2 products that are available. You can just go online on yours-customized.mini, and you can choose 2 different products. It's a side scuttle or the decoration plate. You can personalize this for your use, you can order it, and we directly send it to you worldwide. And this is just a starting point for us. And we want to do many, many more things there as well. In order to do some expectation management, I won't give you a blueprint today, what you should do to bring additive manufacturing into your automotive company or whatever company. I want to give you some ideas of the project itself, and maybe also how long it took and what it needed to make it successful. So we started with initial ideas, early prototypes on SLS, Lightning, things we provided to the design team. We showed them some stuff that could be done. In 2013, we had the first concepts for personalization. We presented it. And then we were starting to scout for the right technologies. In 2015, we did an investment in companies like Carbon. We were early stage customers of HP, doing a beta test program. We also had a lot of EOS machines for testing in-house. And so in 2015, we were the first company launching a field test on clip technology, or DLS, how you call it, for Drive Now. That was a name-giving campaign. Everybody could provide a name. There was a vote, and we had 100 minis driving through different countries in Germany with a nameplate on their side. And this was a good test for us. We had them on the field for a year at this time. Nobody else had parts like this even available. So you should be very fast at the beginning. Then I remember April 2016, where we got the target agreement. There was a meeting, I had to come up, and the product line said, So you have the chance to prove that additive manufacturing can be used for the new Mini. Do you really want to do it? And I said, yeah, why not? They said, it's okay, do it, but we won't move the start of production in January 2018. If you can really provide this until that day, we do it. I came back to the team, I told them, I think the next 1.5 years we have a lot of work to do, but we did it. We went through all the approvals we had to do. And I think there were many things we knew, but there were also a lot of unknowns for us, things that came up while the project. And those are exactly things I want to show you today. First of all, we started with the product. We had some ideas in mind, but I'm not a designer. We are all engineers, so it's not our home turf to do some designing on stuff. So we had a lot of ideas there. We had some initial things, and those are really old concepts from 2013, but you already see the product itself, the idea of the product that could be personalized was already there. Some things came up, we got rid of other things, so some ideas were maybe not so successful, but we had to do some ideation at this point. In the next step, you need to create all the fans in your company. So for us, this meant IT, this meant designers. We had a lot of co-creation workshops together with all the different parties in the team. Also marketing, after sales, everybody who deals with a customer has to be involved in there and has to be a fan of the product. So here at this time we were discussing about what kind of parts do we have, what kind of patterns do we want to have, what kind of logos should we put in there. It's easy for a design, or from a design perspective. They just paint something in 2D. But for me as a production guy, it's not that easy. Just one example. I need to prove that I can really manufacture all this stuff they want to have. So minimum gap sizes, minimum features, and we focused on 3 technologies, on laser sintering, on multi-jet fusion, and on DLS. So I really had to provide this and test this for all these technologies. And here's just an example from an SLS job with different plates we produced in order to test gap sizes and features. And you can see we already had to do this in our final production setup. We have a power shot unit afterwards, so I really need to consider this, that some ceramic spheres might stick into the thin walls we have or in the features we have. So at the beginning of the whole project, we had to already set up the whole production line and know about the materials, which is sometimes tough. You can't iterate there anymore. But we iterated on the product. So it was really funny. The first event where we showed it to public was Mini Takes the States in 2016. That is a nice race through the United States. There are a lot of Mini enthusiasts. We said, okay, let's have a look at them, show them the customizer that was an early prototype to see how the usability is, if they like it or not, if they accept it or not. And we had some side scuttles with us in different technologies. The feedback was, can I buy them? Please, please, give me one, come on. And we said, like, yeah, sorry, we don't have so many with us. But we saw at this day that editions are really, really important for specific events like the MTTS. So this year in 2018, we already had the first MTTS edition that was sold there. And it was a really good feedback because we had a lot of fans, and they give you the honest feedback because they still want to be fans in the next 5 to 10 years. With this feedback and all the knowledge we gained over time, we came back. We did the final approval, and it looks so simple, but to be honest, this is not a walk in the park. I mean, there are some decoration plates. In this case, they are laser sintered, but they are painted. That means we need to do the automotive standards. This is a 2-layer paint we have. We developed the paint especially for additive manufacturing, especially for this product. And it has to match to all the parts within the car or in the exterior of the car. So we really had to develop colors, therefore, and a painting process. And the reason why I displayed craftsmanship as one part of this project is they're all hand-painted at BMW if you order them. Then, in the next step, you go through the final approval. That means you really discuss what is okay, what is not okay. You create a failure catalog, therefore, in order to see what kind of tolerances do we want to have in the next step. What kind of color difference is acceptable, what is not acceptable. And then if you do this, you're quite far already with your project. That means the next question we had is, how do we want to interact with the customer? We have some customizer softwares online for cars, but we did not know how could we interact with a customer who does the designing. We want to guide somebody to design something, and the person should like it. So I want to guide you through our current version of the customer. First of all, you decide what do you want to customize. In my case, it's the side scuttle. You choose a color. They all match to every typical color you can choose for Mini. The next step is you choose a pattern. There are various patterns available. And the funny thing is, with the SOP, we did not stop. We released new things, new patterns, and also new icons on a monthly basis. So that's really interesting also for us. We don't stop the development of the project with the start of production. We are still working on it. We are getting feedback, and we do iterations and improve the whole product. Until there, it was quite easy. Now it gets really tough. If you want to put a text on those parts, it's easy for an eye. So I have the heart. I don't know if you can see it. I love TCT. Doesn't work. It's a trade name, so we can't use it. The problem is if you usually see those projects with personalization and somebody can put a text on it, there is somebody sitting there behind it and going through all those things. If there are bad words, if there are trademarks where you could get into trouble and things like this, the person usually does not know all the things. So we went to all those agencies and asked them, what can you provide for us? Everybody said, you can have this, yeah, that. So we bought all of them, and we developed our own blacklist. So it's the strongest blacklist you could ever have. For example, if this is part of your name, and it is already somewhere that we can't use it, then we come to a manual process. You can ask for it, you can say, this is my name, and then we can make it available just for you for this print. It was good. In this case, I Love Birmingham worked, so I was really, it's always interesting for me when I give this presentation to see, can I use it or not, the trade show name or not. So this was the first experience. Now you order your part, and then you get it in a perfect box. But what is the next thing? You don't want to go to your dealership in order to install it. You want to do it yourself. It was easy for the side scuttle. You can just easily put it out. That's no problem. But if you come to the dashboard, there are so many things. If you need a special tool or something, it won't work. In our case, we developed the tool. You see it up there, a multi-jet fusion tool. And I said, all the products that are in the car have to be done easily by the customer. Everybody told me, sorry, we have special clips in the dashboard. That doesn't work at all. So we had a lot of workshops. We had a lot of internal friction, I'd say. And we found a solution. And the solution is a little sphere. So some years ago, one of my colleagues filed a patent on using spheres for assembly. And that's the perfect solution for us, for additive manufacturing, in order to keep a part in place, keep tolerances where they are, and we also provided head crash tests on this. So the sphere perfectly works. But we had to develop our own carrier. So in this case, it's an injection-molded two-component carrier. The black component is a TPU, and the back part, the stiff one, is a PC ABS. So we had to fully develop this. But the experience now, if you want to remove the decoration plate, is perfect. Believe me, I did it, I think, thousands of times. Whenever I got a Mini at home, I asked my kids, hey, can you do it? And they did it the whole day. So they really liked it. They did not destroy anything, but this is important. We don't want that you do it yourself and you have a scratch somewhere on your dashboard. That's not what we think is a good service. So it has to be easy for yourself. Yeah. And then the easy part, production. That's my home turf. All the other things were just hobby things around. Those unknown unknowns we had while the project. And the production part, I thought this might be maybe the hardest one, But at the end, it turned out that there are so many IT things and so many other things that were even more complicated than getting our production right. How did we start? Well, the first idea is, if you talk to marketing and you ask them, or somebody who doesn't know about additive manufacturing, how should this work? And they say, yeah, it's easy. You have this kind of customizer. I just have it here on the phone. That's no problem. I just order the part. It goes to a printer at BMW, and you send the part. I said, yeah, that's right. But this is not that easy. First of all, I always want to talk about the raw part production. The additive manufacturing process is a raw part production technique we use there, and this is not the final part. But let's start at the order. I want to give you a short look behind the curtain. As I mentioned, it will not be a blueprint in order to show all the things we did and developed, because this would be kind of boring for you. But if we start at the beginning, you customize, you place an order. It needs to go into an enterprise resource planning system, so the order has to be placed in our production system. And in parallel, something happens. The part needs to go into my production system as well. But I don't get your name, your data, or anything. This is externally. We are not allowed to work with your data. So in this case, I just get the part, the CAD file and STL file today, or we can also use 3MF files. And at the backside, we already have a customized part ID. It's not just a serial number. If you have a problem with your part and you call our service and you say, this is the customized parts ID, then we have the chance to take a look at the part. When was it produced? Who produced it? Where might be the problem of this part? So I always need to identify the individual part we send to you. We do it with this customized parts ID. And even the discussion about amount of digits and characters we use and stuff like this can take really long and might be a showstopper for such a project. And the next thing we did is using a digital machine code. So the customizing platform is able to already produce a DMC code on the backside of the part. So we have camera systems in all single steps. We record the part, and we can identify it. We know when it was produced, and we know the whole history behind it. A DMC code is completely different for SLS, for multi-head fusion, and for DLS. So you have to work with all those technology specifics as well. Now, the file is in our production system. Next thing was, I was asking all the big companies, can you provide a manufacturing execution system for myself? They were like, yeah, BMW has so many different MES, so that's no problem. And I said, yeah, but this time for personalized parts and 3D printed parts. Everybody said, no, sorry. Within 1.5 years, no. We can provide you a proof of concept in 2019, maybe. I said, like, start of production is January 2018. We need it there. So we had to develop it on our own. The good thing is we started in 2011 to develop an own platform internally for prototyping. So we just had workshops again with the whole IT team discussing what could we do using this prototyping approach we have, creating a whole MES for personalized parts. And the best thing is if you really develop it on your own, you gain so much experience with it, and you know about all the limitations that might come up. So we did it. That means the files go into the system. They are automatically placed to the machines. They are also, for every position, we have different scaling factors in order to make it the perfect part. We have a slicing process and then the part production. After this production step, we identify the part, we give it to the paint shop, and this picture down there is really a picture out of the paint shop we have where those parts are really painted. And then we do the assembly, packing, and we send it to the customer. In between, there are different quality gates. I mentioned we take a picture of the backside, of the front side of the part. We have some inspections also from a dimensional perspective. This goes all in an archive together with all the production data we have. We record the batch size, we record the machine we had, we record even all the data out of the MQS we have or the mixing systems we use. So everything is stored, and whenever we get in trouble, we can go back and have a look at it in order to gain experience again. So, and this was maybe one of the toughest challenges we had to create this kind of system around, because today there is no service provider who could do this for you. Then, achieving the technical readiness. This is something that is really important for us. So, we separated this in 3 different steps. The first one is benchmark and research. We need to know what is possible, what is the state of the art, what might be the state of the art when the product will be launched. And that means we do a lot of technology and materials performance tests at the beginning. We scout for new startups, we take a look at them. If they have something, we always do cost analysis behind it. We have a cost engineering team that is calculating the final cost of those products, sometimes even before the company really knows about it. And then we decide if we want to do strategic partnerships or if we should do an investment in this company, because this is really important. We did a lot of investments in the last years in carbon, in desktop metal, in different things in the additive manufacturing area. And this is really important, to have an early connection to those companies, tell them what we need, and see what they can do in the future and what they will develop. Then in the next step, the material and technology approval. Here we talk about in TRL 2. We start with an FMEA. We need to know what happens or what are the influencing factors on an SLS machine, multi-head fusion, or DLS machine. From an operator side, from a material side, and all the things where it is operated. So this is also a tough challenge if you do it in parallel for different technologies and materials. On the other side, there are also positive effects if you do it one generic approach for all the things, because then you can scale it up and you can do new things quite easily. So we went through the FMEA, we did machine capability testing. That means we printed thousands of tensile bars in the worst direction. And we tested them, and we tested the influencing factors on their mechanical properties in order to see what kind of influencing factor might lead to what kind of break. And then the last step is the process and part approval. So we have a machine and a production system that is ready. Now we go to the part. Before, we are only doing samples. Now at the part side, it's really interesting. You need to start with an DOE. So you need to see what kind of statistical tests do you have to do. We can't do a 3D measurement of every part we sell. We couldn't. Nobody would like to pay therefore. But you need to set up the statistic behind it. And then you do different tests within the production, and you need to find out those areas where you tolerate a part or not, depending on different factors you have. So in our case, it's maybe the distance of spheres. And single things are measured according to a program. Not only the geometrical stability has to be given, the most important thing, especially for the decoration plate, is the head crash test. So if you're not having a safety belt with you and you go into an accident, the dashboard itself has some passive security activities. And in this case, the thing is the decoration plate must not break. And we have to prove this over several jobs, over several batches, and different things we had to do and the DOE behind it. And there are some engineers in here. Engineers always like to break something, so take a look at this video. This is one of the tests where we use high-speed cameras and also measure a lot behind it to see what happens. So in our case, the decoration plate does not break on different points. We had to fully test this and provide this as our knowledge behind it. According to those things, you need to set up the quality routines, of course, because everything that might happen will happen in the production. This is one of the standards you should really consider. That means the documentation behind it, the instructions, and all those things, they really need to be safe, fail-safe. Everybody should understand it in the production line. So we went through this, and we were able to hold the SOP in January 2018. And what I mentioned earlier was the thing with special editions. So the first special edition we had was the one for Meghan and Harry for their marriage, mini provided a car for their charity institution they have. And I remember the day when the design team came up and said, hey, man, we need to develop something. Let's do it, let's do it. We said, no worries. Let's take the customizer, and we can do it easily. It did not take weeks. It was a question of hours to do this. Maybe doing some things that were not available at that day, but we are able to do this for those editions in a quite easy and comfortable way. And that was a really good thing for the design team to understand that we can have those specific areas in the car, we can modify them for those editions, and yeah, we are really getting into speed now with it. So that was a little bit of the playground I had for Mini over the last years, because I think as a British project or product, it is a nice project to display here. In parallel, we did a lot of co-development. Also, the effects we had when we started generic approval tests for polymers can be seen on the metal side as well. So this is just one of the projects we had. In parallel, many different projects came up. So we had a really nice playground. And I want to end the presentation with a short movie about this playground. So we are used to full speed, and this is also how we deal with our projects. We always ask ourselves, what is next? So in this case, at the end of this short movie, you saw our new campus that will be opened mid of next year, especially to train our engineers, our designers on additive, to do all the things we need for prototyping, personalization, after-sales production, and serial production in this one building, in order to scale it up into our whole production network for the future. So I think we try to really develop this vision of using additive in the automotive area, and I think we are just at the beginning of it. Thank you, and I think maybe we have some questions.
Over here, thanks very much, Dominik.
Hello, I'd like to know if BMW is willing to invest more and for critical components and in large volumes. Would you be able to produce not just aesthetically parts, but something like under the hood components or cabin components in high volume, like thousands of parts? Thank you.
No. So one basic thing is we don't do any showcases. Usually if we start something, we want to use it afterwards. And of course, we see that the costs may come down in the future from a machine perspective, material perspective, and especially also automation is an important thing. But only automation where it is needed, not everywhere, not because we can do it, but where it is needed. And of course, we want to prepare ourselves to utilize additive manufacturing wherever it is needed and can help us.
Any other questions? I think we've got time for one more.
It's a super amazing case with a Mini to see additive manufactured part in production. I have two questions, when you can disclose it. How many of these individual parts have been produced since start of production? And the second one, also if you can disclose, what is your next project, in which model we can expect something?
Well, two really tough questions. We don't talk about production numbers, of course. Let's say just one thing. The good thing is, if you start a project, we can a little bit calculate how we want to launch it in different markets, and that's important for us in such a project. So, for example, at the beginning, we did not a worldwide launch. So, as soon as we had the possibility to get more machines and to do more in there, we were able to scale it up, and that's the funny thing with additive. The production numbers are not so important anymore. If you have a blueprint for 2 machines, you can scale it up from this point easily. So that's a good thing there. But of course, I can't talk about production numbers. And also for the next projects, we have some in the pipeline, of course. We always want to see the next thing coming up. But unfortunately, I can't talk about this today. Sorry.